Welcome you all to this video lecture. Today we discuss joint probability density function for pair of random variables. Now let's start with the definition. What is joint probability density function? Actually, the joint probability density function of the continuous random variable x and y is a function that is represented by small subscript capital X comma y of xy with the property that CDF is equal to minus infinity to x minus infinity to y, and in integral you have the probability density function. So means that when you integrate the PDF you get the CDF. So this is the definition of this way you can calculate the PDF. Okay. Now, to calculate the PDF, so it's better to use Theorem 5.1, which says that PDF of pair of random variables x and y is actually the partial second derivative of CDF for joint CDF. Okay. Now, let's understand this concept. Let's do an example. Example is based on actually what you say 5.2. This is example 5.6 that is based on 5.2, and he says that equation 5.5, that is this one, gives you the CDF. Now question is, you have to calculate the joint PDF of pair of random variables. So if I look at this, I just copy this example here so that I know exactly what was the equation. So if I look here, if you remember, if I go back and look at this theorem, and this theorem says that you have to take the second partial derivative with respect to x and y. Now if I move to next one, look here, there are 6 regions where this CDF is defined. So for first region only x is defined, so it is already 0, y is already 0. This is the one region where we have variation in terms of x and y, that is x minus 5 times x minus 6. But in fourth region we have only y terms. Similarly in fifth region we only have x terms, and last region we have 1. So this means that when I take the partial derivative of y minus 6 with respect to y, I get 1, but with respect to x it is 0. Similarly for x, this partial derivative with respect to y is 0. So this means that only left with this region, that is x minus 5 and y minus 6. That gives you some um, you can apply the partial derivative here. Okay, so let's look here. So for second one we just apply the partial derivative and it becomes 1. So this means that overall regions, the joint PDF is 0, only 1 when you are in this region, that x is between 5 and 6 and y is between 6 and 7. Now let's do a look at another theorem, and this theorem is 5.6, and it says that a joint PDF that is represented by small f with the random variable pair of random variables x and y now has the following properties corresponding to first and second axiom of probability. So actually this PDF actually follow the axioms of probability. So if you remember, one axiom says that probability is always a non-negative number. So similarly PDF is a non-negative number. Second is that when you add up all the probabilities, it becomes equal to 1. So look here, it is in same line that you have integrate PDF from minus infinity to infinity, your result is 1. Now the next theorem, it says that the probability that the continuous random variable xy are in A is given by this thing. Okay, so actually you have to put the area where this event is defined, and you just solve it. You can easily calculate the probability of that event. Now let's understand this using an example. An example says that we have a pair of random variables x and y have joint PDF is given to us, that is for x and y is equal to 0 when is equal to c when you are in x is between 0 and 5 and y is between 0 and 3, otherwise it's 0. So this is given to you. Now question is find the constant c and probability of event A. Now for constant c we have to go back and look at this theorem, that is 5.6. We can use this property to find the c. Now I use this property, okay, that this is defined from minus between infinity. So if I look at the CDF, it is defined between only these intervals. So I just use the limit of 0 to 5 and 0 to 3 for x and y respectively. So look here, 0 to 5, 0 to 3, c dv dx equal to 15. So from here we easily calculate the value of c. Now next question is to calculate the probability of event b, and b is defined between 2, 3 and 1 and 3. Okay. Now how you do that is very simple. You use the same formula. Now use 2 to 3 and put in the value of c. You usually calculate the probability, that becomes 2 by 5. Now this is the example, this one, okay, 5.8, and it says that now x y have joint PDF is given to you as a rectangle that is defined between 0 and 1 on both axes. Now the question is we have to find the CDF. Okay, now for that reason we have to do the integration, because we know that CDF and PDF has a relation that defined using integration. Now for integration we have to look at all possible uh, scenarios where we can calculate the CDF. Now how we do that? So basically if I go back, this is the what I told you. For example, this is the area and this is the region that is defined by x is less than 0 and y equal to x. So there's no interaction, so this means that probability is 0. CDF is not defined here, it is 0. Similarly, when I just push this further and so that y is greater than or equal to 0 but x is less than 1, so now for second case we just plug in the limits and we calculate the result. Now the third one is that if x is this one, where we say that x is between 0 and 1 and x is less than y. Okay, so in lastly what you did actually, we have this range that is more than this region of CDF. So in this way we calculate the CDF from the PDF. So this is the formula that they can use to find the PDF. Now look here, first case is 0 to x and uv 2v equal to 2x. Similarly, in second case, we have interval from 0 to y and v to 1. We solve it, we calculate the result. So for all intervals, we get this result. Now let's do another example. An example says that random variable x and y have joint PDF given to you is 1 by 15. The question is, what is the probability of A and that is equal to for y is greater than x? Now to apply the theorem, integration over the interval using integration by parts. So let's assume we have two pairs of random variable x and y, and we say that y is always greater than x, so this is the region which is satisfied. Now probability of A that goes to 0 to 3 and x to 3. Okay, 1 by 15 dy dx. So on solving, we easily calculate the probability equal to 3 by 10. Now, quiz for 5.4, it says that you have given PDF given to you. First, find the constant, then the probability of the event. So, for constant, we just have to use the theorem where we can say that if we integrate this cxy with respect to minus infinity to infinity for x and y, and then put uh, equal to 1, and we can calculate c here. Okay, so look here. So basically, to find the c, we will use this axiom, this theorem where we in, introduce using the axioms of probability. And the main idea is when we do the integration from minus infinity to infinity, so overall integration is equal to 1. So from here, when we do that, we easily find c. So look here, minus infinity to infinity f x y. Just plug in the values and solve it. We easily calculate the c equal to 1. Now next is calculate the event a. So if I go back, so look here, this is the event x square plus y square is less than equal to 1. So this is actually an equation of a circle with a unit radius, and it says less than means that you have a circle and you are including all inside the circle. Now look here, probability is you have to find the area to solve this. So this become a bit difficult to solve under this area. So what we can do is to convert into polar coordinates. So what we did, we put x equal to cos theta, y equal to cos theta, and dx dy is equal to r dr d theta. Now when we plug in the values, and what we get, because it will traverse whole area, so it becomes 0 to pi by 2, and for r it becomes 0 to 1. Okay, now when we plug in the values, we easily calculate the result that becomes 1 by 8. Now I will stop here for this lecture and will continue in next lecture.